Hey everyone, welcome back to the Raspberry Pi mini series. We just got our Raspberry Pi set up in the previous segment and we learned how to interact with it both from a GUI perspective and remotely as well, which was pretty cool. And now we're ready to write our first program in Python, and that is the Blink LED program. I'll walk you through the hardware setup and the code, so be sure you watch the previous segments to make sure you are caught up, and let's get started. So before we get into discussing the hardware and code, let's briefly touch upon the pins of the Raspberry Pi because we haven't up to this point in the course. And so it's important we categorize and understand these pins at a high level when we are working with the Raspberry Pi, because we'll pretty much be using them with every project in the future. So on the board, as you see there is a 40-pin header on the Raspberry Pi 4B model, as well as other Raspberry Pi models up to the 5. They share the same 40-pin header, and these pins can be categorized into different categories. So first of all, we have power pins. So a few pins on the board are known as power pins, which provide 5 volts or 3.3 volts of power, and they can be used to power external devices. We also have ground pins as well. So some pins are ground connections, essential for completing electrical circuits. So pretty much any component you attach will use a ground and a power pin. We also have GPIO pins, which are general purpose input-output pins. They can be used to send or receive signals to things like LEDs, buttons, and sensors. And there are also special purpose I2C pins used to talk to sensors and devices like temperature or motion sensors. So we'll be using I2C pins in the next segment, where we'll be interacting with a temperature sensor. We also have some other special purpose pins like SPI pins. So SPI is great for faster communication with components like displays or flash storage. We also have UART pins. So this is used for serial communication, such as connecting to a GPS module, an external Bluetooth module, and just any device that uses serial communication. We won't be using UART in this course, but if you are working with Raspberry Pi in the future, you are bound to interact with some module that requires a UART pin, and thankfully the Raspberry Pi has those. And now not everything on the Raspberry Pi is part of a pin header. For example, there is a dedicated CSI port for connecting a camera module, and this is perfect for things like security cameras or photography projects or live streaming something, and it's really easy to use that camera module on the Raspberry Pi. The Pi also has an audio option with a 3.3mm headphone jack for sound output, and it also supports Bluetooth, so it has a Bluetooth module on the board. And finally, just keep in mind that the GPIO pins for the Raspberry Pi operate at 3.3 volt signals only, so avoid sending them 5 volts to prevent damaging them. And there you go, that's pretty much a quick overview of the pins and the ports that make the Raspberry Pi such a powerful tool for electronics projects. Okay, so in terms of hardware setup, we pretty much have the same peripherals as we did in as we did in the segment before this, where we have our HDMI, we have the power, we have our keyboard and our mouse attached. But on top of that, now what we have is we have this little breadboard with some simple components here, and I'll go ahead and talk about this very briefly. So first of all, if you've never seen a breadboard, this is just a piece of hardware where you can make electrical connections in a more seamless and clean way, because if you do not have this breadboard, pretty much what would happen is these wires would be all over the place and it would be hard to organize things. So we typically use a breadboard when prototyping because it makes working with your electronics a whole lot easier. So the purpose of a breadboard pretty much is to make your prototyping easier at a high level. So on this breadboard, let's talk about what we have. So let me go ahead and detach these real quick and just focus on what we have on the breadboard. So on this breadboard, first of all, we have this little resistor component. So this resistor is a piece of hardware as well that pretty much will allow the limiting of a surge of current to reach this LED. So you can see we have the LED here on this board. And the reason we want this resistor is sometimes in rare scenarios that there can be an overcharge of current to the LED and it could potentially burn out your LED. So it's good practice to use these resistors when we are working with LEDs like this for our Blink LED project. So we have a resistor on the board, and we see on this board that the resistor, both ends of the resistor are on the same row. So that is row, I'm just using row 16 it looks like, but just make sure one end is on one side of the bridge and one end is on the other side of the bridge, because as you see in the center of the breadboard, it's not connected from one side to the other, but you can connect both sides with a resistor like this. So it's taking current from this side and reaching the other side. So that's what's nice about this resistor, is it does protect the LED from potential burnout. Not that we care too much about these LEDs because they're very cheap, but it's just better to use those. On top of the LED, we have a jumper wire. So this is called a male to female jumper wire. So one end has a tin sticking out and the other end is insertable. So this one we can insert into the the Raspberry Pi, and this other end we can insert into the breadboard. So that's all we're doing. So that's on the same row as one end of the resistor. So let's go ahead and do that. And this is what's going to be receiving power. So this end is going to be receiving power from the Raspberry Pi on a GPIO pin. We're going to be using GPIO 17. So that is the 6th pin from the top. So 1, 2, 3, 4, 5, 6 in this back row. So you see we are using GPIO 17, and if you're confused about that, you could just search pins on the Raspberry Pi online and it'll show you which one is GPIO 17. So that goes to the inputs of the circuits. And then here we have this LED. So this LED, very common. It's just a 2-node LED. So one node takes power. So the longer side is what receives power, and the shorter side is what goes to ground. And then each end of the resistor goes on a separate row on the breadboard. So the longer end attaches to the LED. So you see that the longer end is on the same row as the resistor. Sorry. So the longer end is on the same row as the resistor, and then the shorter end is connected to row 15, and then it has another male to female jumper wire. So this is just going to complete the circuit. Remember how we talked about the ground pin is for completing the circuit? Well, this is the ground pin. It's connected to the shorter end of the LED on row 15, and we're just going to connect it to any ground pin on the Raspberry Pi. So I'm just going to use this 3rd pin from the top. So 1, 2, 3, and that is this 3rd ground pin. So this is the completed circuit. Very simple circuits with our Raspberry Pi. We're using a GPIO pin. We're using a resistor to protect the LED, and then we're using this LED to make a light. So that's all the LED does. It just turns on, so it produces a light. And if we have the circuit correctly, we should be able to go into our Python code and run a very simple script that turns on and off this LED. So make sure your Raspberry Pi is on, and let's go back into our Raspberry Pi environment. Okay, so let's jump back into our Raspberry Pi, and we just want to make our Python script. I already went and made it off screen, but I'll just show you how to make it from scratch. So we could just go to the top left, we can go to programming, and we're going to go into an editor. So editors allow us to edit and create code and manage things in our project. So I'm just going to select the Genie's editor. And so this is what is showing when we open the Genie's editor. You can go ahead and make a new file. I already have my file created, and it is blink.py, so I'm just going to open that. And if you didn't have that, you can just go and make a new file and save it as what you like. Make sure you save it as a .py extension, and just go ahead and copy the same content I have here. So let's go over what's going on in this script at a high level. So let me go ahead and zoom in first. Let's see if I can. I believe it's like this or like this. There we go. So I'm zooming in. I hope that's clear now. So in this script, what we're doing, very simple Python script that allows us to blink the LED. So in this first segment of the script, we're just importing some libraries. So these libraries allow us to do things easier in the code, essentially. So the first library allows us to interact with the GPIO pins of the Raspberry Pi. So you can go ahead and import rpi.gpio. Very common library when you are working with sensors in the Raspberry Pi. Next, we have the time library. So this is the time library. It allows you to manage time within your code. So down here, what we're doing is we're actually using time.sleep to wait. So we're going to turn the LED on for 1 second, and then we're going to measure time for 1 second using that time library. Then we're going to turn it off, and then we're going to measure time for a second. And we're just going to repeat this cycle. So the time library allows us to do that. Next, we're setting the constant for the LED pin, so that is pin 17, the GPIO 17, as we talked about in the previous segment. And then we're just going to do some setup for that GPIO pin. So we're pretty much telling Raspberry Pi that we want to start using this GPIO pin at pin 17. And we want it to be an out pin. Remember, GPIO is input output. It's going to be an output, so the GPIO pin is going to send an on or off signal output to the LED, and that is what's going to be turning it on and off. And then we just have a simple debug statement. So this is just going to say turning on and off. And once you get past this point, pretty much what it's going to do is this code is going to try running a while loop. And it's going to run this code forever until you exit the code or turn off your Raspberry Pi. And in this while loop, it's pretty much telling the GPIO pin to first set that LED pin as high. So high means on. And then wait, and then turn it as off. So that is low. And that's pretty much what's happening in this code at a high level. We have some exception handling here, so keyboard interrupt. So that's if you interrupt the program with your keyboard, so you can exit with Control C, I believe. That'll exit the program, and then after that is all done, it'll finally clean up the GPIO pins. This is just good practice to reset the GPIO pins after you are done running any program that use GPIO pins. So I hope the program at a high level explained was simple enough for you to understand. And now that we understand the program and we have everything connected, we're just going to go ahead and run this program. So in order to do that in Genie, we can go ahead and click this paper plane here, and it should send it to the Raspberry Pi, and the LED should start turning on and off. So it looks like it is turning on and off. If yours is not turning on and off, some simple troubleshooting, you can check your hardware components, make sure everything is touching the bottom of that breadboard. I just tried turning this on and off camera, and it wasn't working, and what I realized was my resistor wasn't pushed all the way into the breadboard, so that could be one thing as well. And just make sure everything is oriented properly and you are using the GPIO pins, and you should see it turn on and off as you are seeing here on the screen. Okay, so quick extra thing I want to show you now that we have our blink LED running. We could run the same program remotely from our computer. So I'm on my Mac again, and I'm going to show you how to SSH, or we already know how to SSH from the previous segment. So I'm just going to show you how to run that program via SSH. So we can go ahead and SSH to our Raspberry Pi as we did before this. Same thing, just go ahead and type the password on your Raspberry Pi. We're logged in now to the Raspberry Pi remotely from our Mac or your Windows or whatever machine you're on, and we could just go to the directory that this is saved on. So it's on my desktop, and I could just go see the files that are in there. So it looks like the blink.py is on my desktop, and I can actually see what's in this file from remote, and I could just do vi blink.py, and you can see it's the same program. This is the one we wrote on the Raspberry Pi, and looks good. So I'm just going to go ahead and run this program remotely, and we can just go ahead and quit. That is :Q exclamation mark. So VI is just another form of editing a file, and you'll probably use it more in the future as you get more advanced. So now that we confirmed it's the file, we can go ahead and run it by typing in the Python command in the terminal and typing blink.py, and it should go ahead and run that same program without having to be in the Raspberry Pi. The Raspberry Pi is just turned on, and I just wanted to show you real quick that SSH is powerful because you can run this program without having to access the Raspberry Pi from a monitor. Okay, so that sums it up for today's lesson. I hope you got a good overview of the pins on the Raspberry Pi and the other types of connections you can make with the Raspberry Pi 4B. As you saw, a very powerful module, and it was incredibly seamless to set up our Blink LED program with the Raspberry Pi GPIO pins in the Python programming language. And we're also able to run that same program remotely using SSH, which we learned about in the previous lesson. So I showed you a little extra segment there where we used SSH to actually run the same program without a monitor. So keep that in mind. I just wanted to show you that real quick as an extra segment so you guys can potentially use that in the future. So we learned a lot this lesson. We wrote our first program, we interacted with our first piece of hardware. Now let's take it a step further and use a sensor that provides to us real world data. So we're going to be using a temperature sensor in the next lesson to build a real weather station. So a little more involved, but a little more exciting as well. So that being said, I just want to thank you for watching this lesson, and I hope you stick around and meet me in the next one. See you soon.